Hello students, today we are solving a NEET grand test paper. This is completely based on NCERT textbook level only. See the first question, the maximum number of molecules present in. How to calculate maximum number of molecules? Maximum number of molecules, number of moles or number of molecules is calculated by using the formula weight by molecular weight if weight is given. Instead of weight, volume is given, then given volume divides with 22.4 liters. First of all, 4 grams of hydrogen, weight is given. Weight of hydrogen is 4 grams, molecular weight of hydrogen is 2 grams. Then number of moles or molecules is equals to 2. Ammonia volume is given volume divides with 22.4, then number of moles or molecules is equals to 5. CH4 64 by 16, then 4 moles, and one more option is given, 12 gram atoms of oxygen. What is gram atom? 1 gram atom is equals to 1 mole of atoms. 12 gram atoms is equals to 12 moles of oxygen atom. Generally, oxygen exists as O2 molecule. So number of moles of O2 molecules is equals to 12 divides with 2, that is equals to 6 moles. So maximum number of molecules are present in 12 grams of oxygen. Third option is correct option. The next question is matching type of question. Name of the reaction, reagent used. First name of the reaction is HVZ reaction. In HVZ reaction, bromine red phosphorus is used. Iodoform reaction, NaOH plus I2 is used. A3B1, only one option is there, that is fourth option. Ettard reaction, we are using CrO2Cl2 for the hydrolysis. Getterman-Koch reaction, we are using COHCl in the presence of anhydrous AlCl3. See the next question. For the reaction A plus B gives rise to C plus D. Here A is gas, B is gas, C also in the form of gas, but D is in the form of solid. 2 moles of A, 3 moles of B and 1 mole of C are present in a 10-liter vessel. If Kc of the reaction is 3.6, then reaction proceeds in which direction? So you must calculate Qc. So hint, Qc is less than Kc, then reaction proceeds in forward direction. If Qc is greater than Kc, reaction proceeds in backward direction. Qc is equals to Kc, reaction is in equilibrium. How to calculate Qc? Qc is equals to nothing but ppc by prc formula. Only consider gases. Concentration of C by concentration of A into concentration of B. Here number of moles of A, B, C are given. Number of moles converted to concentration term. How? The number of moles divides with volume. How much volume is given, Amma? 10 liters of volume. So 1 by 10 divides with 2 by 10 into 3 by 10. That is equals to 1 by 10 into 10 by 2 into 10 by 3. 10 cancel. Then you will get 10 by 6. 10 by 6 value, 10 by 6 value is 1.66. So Qc value is 1.66, Kc value is 3.6. Qc is less than Kc. Reaction proceeds in forward direction. 1.66 is less than 3.6. The next question is statement based question. Statement 1. Some organic liquids can be purified by steam distillation. Yes, this is correct. Generally, steam distillation process is used to separate and purify Compounds like aniline, nitrobenzene, essential oils from non-essential volatile impurities. The principle involved in steam distillation is that liquids immiscible in water possessing high boiling point and are steam volatile. Principle is also correct. Both statement 1 and 2 are true. The next question is, in which of the following equilibria Kp not equals to Kc? Kp not equals to Kc. If delta n is equals to 0, Kp is equals to Kc. If delta n is negative or positive, then the value of Kp is not equals to Kc. How to calculate delta n? Delta n is equals to Np minus Nr. Only consider gases reactants and gases product. You can consider the fourth option. Delta n is equals to number of moles of products 2 gases products. Number of moles of gases reactants is only 1. 2 minus 1, 1. Delta n value is equals to positive. So Kp not equals to Kc. The next question is, intramolecular hydrogen bond is exhibited by. What is intramolecular hydrogen bond? Hydrogen atom and high electronegative atom from a bond within the same molecule. So hydrogen atom, high electronegative atom forms a bond within the same molecule. So correct option is fourth option. 2-hydroxybenzoic acid or orthohydroxybenzoic acid. C double bond O, OH. This is OH. Between oxygen and hydrogen bond is possible. That is intramolecular hydrogen bond. The next question is, in which of the following process delta S value is negative? First of all, hint, suppose solid reactant is converted to liquid product or liquid reactant is converted to gaseous product or solid reactant is converted to gaseous product, the value of delta S is equals to positive. Liquids are converted to solids or gases are converted to liquids or gases are converted to solids, then the value of delta S is negative. See the first option, H2S gas is converted to 2H gas. Here number of moles of product, gases products are increases, so delta S value is positive. N2 gas 1 atmosphere, N2 gas 8 atmosphere. Left to right, pressure increases. Delta S value is inversely proportional to pressure. If pressure is increases, delta S value decreases. That means the value of delta S is negative. Why? If pressure increases, volume occupied by gas particles. Volume occupied by gas particles or decreases. Volume decreases, automatically randomness is also decreases. So the value of delta S is negative in case of B. C, left to right, number of moles of gas particles are increases. Solid is converted to gas. Only delta S is negative in case of B option. So the second option is correct option. Second option is correct option. Among the hydrides NH3, PH3 and BH3, the hydride with highest boiling point is X and hydride with lowest boiling point is Y. What is X and Y? Already I given boiling point of hydrides of 5A group elements, 6A group elements and 7A group elements. In this question, NH3 is given, PH3 is given, BiH3 is given. Highest boiling point compound is BiH3, lowest boiling point compound is PH3. So correct option is third option. Consider the following structure. The correct sequence of these carbocations decreasing order. First of all, first carbocation is vinyl carbocation. Second carbocation is 1 degree carbocation. Third carbocation is allyl carbocation. And fourth carbocation is benzyl carbocation. Order of stability of carbocation is 3 degree greater than, benzyl greater than, allyl greater than, 2 degree greater than, 1 degree greater than, methyl greater than, vinyl greater than, aryl. So benzyl is more stable, starts with 4. Benzyl after, allyl is more stable, 4 after 3. First option is correct option. The correct IUPAC name of C2H5 taken 4 times C. This is the structure of C2H5 taken 4 times C. Give the numbering 1, 2, 3, 4, 5. Third position, branch is present. Third position, one more branch is present. Branch name is ethyl. So 3, 3 diethyl pentane. Third option, correct option. Which of the following halide shows the highest reactivity towards SN1 reaction? Order of reactivity of SN1 reaction is benzyl greater than, allyl greater than, 3 degree greater than, 2 degree greater than, 1 degree greater than, methyl greater than, vinyl greater than, aryl. Here one more important point is benzyl C6H5CH2, phenyl formula C6H5. C6H5CH2Cl, this is benzyl chloride. Highest reactivity. So no doubt, benzyl chloride, highest reactivity. Identify A and B in the following reaction. 2-methyl propane reacts with KMnO4. 2-methyl propane is a alkane with 3 degree carbon atom. In the presence of KMnO4, oxidation takes place and it gives corresponding alcohol CH3, COH, CH3, CH3. Further reacts with H3PO4. Role of H3PO4 is it acts as dehydrating agent, remove water molecule, then it gives alkene CH2 double bond C, CH3, CH3. Now alkene undergoes ozonolysis. Reductive ozonolysis break the double bond, add left side oxygen atom, right side oxygen atom. Then it gives CH2O. CH2O is also written as HCHO plus CH3CO CH3. So the correct option is second option. Glucose does not react with which of the following reagent? We know that glucose is a aldohexose. In case of glucose, aldehyde functional group is present. But the aldehyde functional group is not free. In this, how you can decide absence of free aldehyde group? In this, aldehyde group is involved in an intramolecular linkage between first carbon atom and fifth carbon atom. So the aldehyde group is present, but the aldehyde group is not free. That's the reason it does not give Skiff's reagent test as well as does not react with NaHSO3. So the correct option is first option. Match the following. COEN twice Cl2Br. COEN twice. En is a bidentate ligand. So it exhibits optical isomerism, geometrical isomerism. Optical isomerism, geometrical isomerism, and ionization isomerism. It dissociates like ions Br minus, complex gets positive charge. So compound A exhibits optical, geometrical and ionization. So correct option is second option. K2Cr2O4 thrice. Only bidentate ligands are present. So it exhibits optical isomerism. PT, it is look like M, A, B, C2. Exhibits geometrical isomerism. Exchange of ligands between coordination entities, it exhibits coordination isomerism. The ground state energy of a hydrogen atom is minus 13.6 electron volts. The energy of the second excited state of helium plus ion in electron volts is. Helium plus is a hydrogen-like atom. For hydrogen-like atoms, energy is calculated by using the formula minus 13.6 by n square into z square, where z is equals to atomic number of hydrogen-like atom. Atomic number of hydrogen-like atom is 2 and n is equals to orbit number. It is in second excited state. The value is also 2. Substitute minus 13.6 by n square. N is in second excited state. Yes, second excited state, not second orbit. Sorry, second excited state, not in second orbit. Ground state, n value is equals to 1. First excited state, the value of n is equals to 2. Second excited state, the value of n is equals to 3. N value is equals to 3. 3 whole square into z value is equals to 2. 2 whole square. Simplify, then you will get minus 6.04 electron volts per atom. So, third option is correct option. The number of sigma and pi bonds in acrylonitrile formula CH2 double bond CH single bond C triple bond N. We know that single bond is always sigma bond, double bond contains 1 sigma bond 1 pi bond, triple bond contains 1 sigma bond 2 pi bonds. Single bond sigma, double bond contains 1 sigma 1 pi, sigma bond, triple bond contains 2 pi bonds, 1 sigma bonds. Total number of sigma bonds 6. Total number of pi bonds is equals to 3. Arrange the following in the correct order of their boiling points. We know that first of all, boiling point is directly proportional to molecular weight. If molecular weight is remains same, then boiling point is inversely proportional to number of branches. In neopentane, 2 branches are present. Pentane, 0 branches are present. Isopentane, 1 branch is present. Neopentane, pentane, isopentane, molecular formula remains same. So, boiling point is directly proportional to molecular weight, inversely proportional to number of branches. Isobutane molecular weight is less compared with neopentane, pentane and isopentane. So, starts with 4, increasing order, very less boiling point. Isobutane have very less boiling point. Neopentane, more number of branches are present, 4 after 1. So, the correct option is third option. Next question, statement 1. Oxygen being the first member of group 16 exhibits only -2 oxidation state. Wrong. Statement 1 is wrong. Why? Oxygen in form of oxides, it exhibits -2. In the form of peroxides, it exhibits -1. In case of superoxides, it exhibits -1/2. In case of oxyfluorides, it exhibits positive oxidation state. So, first option wrong. Down the group 16, the stability of +4 oxidation state decreases and the stability of +6 oxidation state increases. This statement is also wrong. Why? According to inert pair electron effect, stability of higher oxidation state decreases down the group and lower oxidation state stability increases down the group. So both the statements are wrong. Next question. The slope of the Arrhenius plot for a first order reaction, slope is given -5 into 10 cube. the value of activation energy for the reaction given R is equals to 8.314 joule Kelvin inverse mole inverse, or R value you can take 8.314 into 10 power minus 3 kilojoules mole inverse Kelvin inverse. Why consider in terms of kilojoules? Because answers are in terms of kilojoules. So straight away you can take in terms of kilojoules the value of R. So Arrhenius plot. Consider Arrhenius equation K is equals to A into e power minus EA by RT. You can apply ln on both sides, then you will get this equation. This equation is in the form of y is equals to mx plus c. It is a straight line equation. Here m is slope. Slope formula minus EA by R. Slope already given, minus 5 into 10 cube is equals to minus, calculate the activation energy. The value of R is 8.314 into 10 power minus 3. Negative cancel. Calculate EA value. EA value 5 into 10 cube into 8.314 into 10 power minus 3. You can simplify, then you will get nearly 41.5 kilojoules. So second option is correct option. The ease of liquefaction of noble gases decreases in the order. Generally, ease of liquefaction is depends on strength of intermolecular forces. Ease of liquefaction is directly proportional to strength of intermolecular forces. We know that in case of noble gases, top to bottom strength of intermolecular forces increases. That's the reason top to bottom boiling point is also increases in case of noble gases. So based on that, second option is correct option. E naught m3 plus by m2 plus is the highest when m is m3 plus by m2 plus, negative for titanium, the value is negative for titanium, vanadium, chromium, positive for manganese, iron and cobalt. Here given options are iron is given, manganese is given, titanium is given, chromium is also given. Question is highest for manganese. Match the following. This is NCERT textbook line. MnBr4 2 minus. Br is a weak ligand field, so it undergoes sp3 hybridization. Magnetic nature is paramagnetic. Why? Regrouping of electrons does not take place. FeF63 minus. Fluorine is weak ligand field. 6 ligands are present, so it undergoes sp3d2 hybridization. A4B2, only one option is present, so fourth option is correct option. Effective collisions are those in which molecules must. So this is based on collision theory postulates. Molecules must have energy equal to or greater than threshold energy. Correct. Molecules must have proper orientation. Correct. Proper orientation takes place. Fruitful collisions are possible and it gives product. Improper orientation takes place, then the collisions are considered as not fruitful collisions, does not gives product. Acquire the energy of activation. This is also correct. So based on this, the correct option is fourth option. Correct option is fourth option. Arrange fluorine, sulfur, oxygen, nitrogen in the decreasing order of electronegativity. We know that nitrogen, oxygen, fluorine are period elements oxygen, sulfur are group elements. Periods left to right electronegativity decreases. Groups top to bottom, periods left to right electronegativity increases. Groups top to bottom electronegativity decreases. Based on that, fluorine electronegativity value is more. Fourth option. Henry's constant in water for 4 gases A, B, C, D in kilobar at 298 kelvins are 144.97, 69.16, 88.8 and 0.413 respectively. The gas that is most soluble. Solubility of gas is inversely proportional to KH value. Not only that, the value of solubility of gas is inversely proportional to temperature also. Here KH values are given. Solubility is inversely proportional to KH value. KH value less, that is more soluble. So fourth option is correct option. Which of the following is not an example of redox reaction? What is redox reaction? In a chemical reaction, both oxidation and reduction takes place simultaneously. Then the reaction is considered as redox reaction. Fourth option is not a redox reaction because here barium oxidation state of barium is +2. Oxidation state of chlorine is -1. In product side also, oxidation state of barium is +2. Oxidation state of chlorine is -1. Reactant side, oxidation state of hydrogen is +1. Oxidation state of sulfate is -2. Product side also, oxidation state of sulfate is -2. Oxidation state of hydrogen is +1. So, gain of electrons, loss of electron process does not take place. So, it is not considered as a redox reaction. The following. Choose the correct answer from the options given below. Okay. Charge required for a redox reaction according to Faraday's laws, Q is equals to N into F. So, aluminium 3 plus is converted to aluminium. How many Faradays of charge is required, or how many coulombs of charge is required? Number of coulombs of charge is required is equals to N into F. N indicates N factor. Here, oxidation state of aluminium is 3. Oxidation state of aluminium is 0, product side. How many electrons? 3, 0 difference is 3. N factor value is equals to 3. N value take it as 3. Multiple with 96500. Then the value is 289500 coulombs. Here Sn plus 4 is converted to Sn plus 2. Oxidation state of Sn is plus 4. Product side oxidation state is plus 2. Oxidation number difference is 2. Q is equals to N into F. 2 into 96500. 2 into 96500. 193,000 coulombs. So D2 A1. D2A1, only one option is there, that is first option. Remaining you can calculate. Here oxidation number is plus 7. Here oxidation number is plus 2. Oxidation number difference is 5. N factor value is also 5. 5 into 96500. Like that you can calculate. Which of the following organic compound responds positively to both iodoform test and Fahling's test? Which gives Fahling's test? Aldehydes gives Fahling's test. Which gives iodoform test? Carbonyl compound, methyl carbonyl or methyl ketone, ethanol, alcohol with general formula CH3CHOH gives positive iodoform test. You can take the third option, ethanol. Ethanol formula, ethanol is a aldehyde. It gives Fahling's test. Ethanol formula is CH3CHO. This group is present, so it gives positive iodoform test also. A chloro compound of vanadium has only spin magnetic moment of 1.73 bm. This vanadium chloride has the formula. Spin magnetic moment is calculated by using the formula mu is equals to square root of n into n plus 2 Bohr magnetons. N represents number of unpaired electrons. You can take the second option, VCl4. Calculate the oxidation state of vanadium. X minus 4 is equals to 0. X is equals to plus 4. Vanadium atomic number 23. Electronic configuration is argon 4s2 3d3. Vanadium is in plus 4 oxidation state. Remove 4 electrons. First remove electrons from outermost orbit. After that excess electrons remove from inner orbit. Total you can remove 4 electrons, then 3d1. 3d1, how many unpaired electrons are present? 1 unpaired electron is present. If 1 unpaired electron is present, the value of spin only magnetic moment is 1.732. So correct option is second option. Next question, matching type of question. Compound is given and its geometry is also given. PCl5, geometry of PCl5 is trigonal bipyramidal. SF4 is seesaw structure. A4B3, one option is there, that is third option. XeF4 square planar and BF3 is trigonal planar. 50 ml of 0.5 molar oxalic acid is needed to neutralize 25 ml of sodium hydroxide solution. The amount of NaOH in 50 ml of the given sodium hydroxide solution. So the given data, molarity of H2C2O4 is given. The molarity of H2C2O4 is 0.5 molar. Volume is given 50 ml. Number of moles, 1 mole of oxalic acid according to this reaction. Calculate number of moles of NaOH. Volume is given 25 ml. Number of moles according to the equation 2 moles of NaOH is required. Now use the formula M1V1 by N1 is equals to M2V2 by N2. Substitute the values. 0.5 into 50 by 1 is equals to M2 into 25 by 2. Then M2 is equals to 0.5 into 50 into 2 by 1 into 25. Simplify now. 2 is 4 into 0.5 is 2 molar. Now question is amount of NaOH. Molarity of NaOH, you know, molarity is equals to weight by molecular weight into 1000 by volume in ml. Molarity 2 molar, calculate the weight. Molecular weight of NaOH is 40. 1000 by given volume is, now given volume is 50 ml. 0 cancel, 0 cancel. 5 2 times 2 times x is equals to 4 grams. So correct option is first option. Alcohols reacts with SOCl2, then it gives haloalkane RCl. SOCl2 is the best reagent to prepare haloalkane from alcohol because it gives gaseous byproducts. Preparation of haloalkane by using SOCl2 from alcohol, the method name is called as Darjan's method. So remove OH group, in the place of OH substitute Cl. Even alcohols reacts with red phosphorus bromine. Yes, remove alcohol group, substitute bromine. So the correct option is second option. Electronic configuration of gadolinium is very important model question. This is check D and F block elements. Gadolinium electronic configuration is xenon 4f7 5d1 6s2. Second option is correct option. See the next question. 2 moles of PCl5 is heated. Initially only reactants are present. Reactant concentration 2 moles. Products are absent, so product concentration is 0. If PCl5 dissociate to the extent of 80%, in 2, 80% of the value is 1.6. That means from 2 at equilibrium, you must remove 1.6. 2 minus 1.6, 1.6, 1.6. Then 0.4, 1.6, 1.6. Calculate the dissociation constant Kc is equals to concentration of PCl3 into concentration of Cl2 by concentration of PCl5. 1.6 into 1.6 by 0.4. 4 times 4 into 1.6 6.4. The SRP for different halogens is in the order of SRP of halogen from top to bottom. Standard reduction potential values are decreases. So fluorine greater than chlorine, greater than bromine, greater than iodine. First option correct option. On reaction with alkaline KMnO4 at an elevated temperature followed by acidification. Alkaline KMnO4 is acts as oxidizing agent. Break the bond between carbon and carbon. Strong oxidizing agent, add 2 oxygens both sides. Then it gives 2 moles of CH3COOH molecules. Third option is correct option. Aniline does not undergo Friedel-Crafts alkylation reaction. Correct. Why? Because aniline forms salt with Lewis acid. Aniline is a base, Lewis acid is a acid. Acid-base reaction takes place and it gives salt. Second statement, aniline cannot be prepared by Gabriel phthalimide synthesis. Yes, this is also correct. Why? Because aniline is a aromatic amine. Aryl halides are not participate towards nucleophilic substitution reactions. Only alkyl halides are participate towards nucleophilic substitution reactions. That's the reason aliphatic amines preparation is possible. Aromatic amines cannot be prepared by Gabriel phthalimide synthesis. Given below are the atomic numbers of some group 14 elements. The atomic number of the element with the lowest melting point. Atomic number 6 carbon, atomic number 14 silicon, atomic number 50 tin, atomic number 82 lead. Order of melting point of group 14 elements is carbon greater than, silicon greater than, germanium greater than, lead greater than tin. Here question is lowest melting point. Lowest melting point is tin. Tin atomic number value is 50. So fourth option is correct option. See the next question. List 1, list 2. List 1 is cations, list 2 is group reagents. First of all, Pb2 plus and Cl2 plus are group 2 cations. What is the group 2 reagent? H2 gas in the presence of dilute HCl. H2 gas in the presence of dilute HCl. Group 3 cations, Al3 plus, Fe3 plus. What is the group reagent? NH4OH in the presence of NH4Cl. A1B3. A1B3. Okay. Group 4 cations are CO2 plus and Ni2 plus. Group reagent is H2S in presence of NH4OH. C4. Yes. A1 B3 C4. Second option. Second option is correct option. Group 5 cations Ba2 plus and Ca2 plus, and the reagent is ammonium carbonate in the presence of NH4OH. If the first ionization enthalpy of lithium, beryllium and carbon are 520, 899, 1086 kilojoule per mole respectively, the first ionization enthalpy of boron. Lithium, beryllium, boron, carbon are period elements. Periods left to right, atomic size decreases. What is the relation between atomic size and ionization potential? Ionization potential is inversely proportional to atomic size. But ionization potential not only depends on atomic size, it also depends on stable electronic configuration. Here beryllium electronic configuration is stable. That's the reason beryllium ionization potential value is more than that of boron. The correct order is lithium less than beryllium greater than boron less than carbon, or lithium less than boron less than beryllium less than carbon. Already lithium value is given, beryllium value is given. Find out the boron value. You can place 487 here. 520 is less than 487. Wrong. Next, keep 950. 520 less than 950 correct. 950 less than 899 wrong. Take 801 correct. 520 less than 801. 801 is less than 899. See, ionization potential is inversely proportional to atomic size, directly proportional to stable electronic configuration. Next question, matching type of question. Principal quantum number, energy of electron in a single electron system. Azimuthal quantum number, relative energies. What is the significance? Relative energies of various subshells in an orbit. A4, B3, only one option. Magnetic quantum number, number of orbits present in any subshell. Spin quantum number, magnetic properties of the substance. So third option is correct option. Identify the product Z in the reaction. Given sequence is related to coal-base reaction sequence. Phenol reacts with NaOH, then it gives sodium phenoxide ion C6H5O minus Na plus, which reacts with CO2. Electrophilic substitution takes place and it gives O minus Na plus, substitute COOH at ortho position. Further hydrolysis, then it gives 2-hydroxy benzoic acid. This is also called as salicylic acid. Third option is correct option. Check coal-base reaction once. Reaction name. BDC converted to chlorobenzene in the presence of Cu2Cl2. In the presence of Cu2Cl2, the reaction name is called as Sandmeyer reaction. In the presence of copper or copper powder, the reaction name is called as Getterman reaction. A2B4. Next question is, complete the following conversion, identify B. This is phenolic OH group, not affected. This is alcoholic OH group. Alcoholic OH groups are reacts with PCl5. We know that alcohols are reacts with PCl5. Then it gives haloalkane. CH2Cl. Remove OH, substitute halogen. Further reacts with AgF. This is halogen exchange reaction. Halogen exchange reaction, exchange the halogen atoms. Then it gives OH, CH2, fluorine. So the correct option is third option. Thank you.